This is lesson 2.3, elementary algebra, multiplication property of equality. So if you remember in 2.2 when we had x plus 2 equals 5, in order to solve that we added the opposite, got rid of that, and gave us x equals 3. We also, if we had x minus 3 equals 12, we added the opposite. And, oops, I'm sorry, what am I doing here? That isn't the opposite, is it? Plus 3, plus 3. Those go away, and you get x equals 15. Okay, in multiplication, you're doing kind of the same thing. Before we were adding the opposite, but the word was opposite. When something is added to the x, we subtract it. When something is subtracted from the x, we add it. So when something is multiplied by the x, in order to get that 5 away, because remember we're trying to get the x by itself. So in order to get rid of that 5, because it's multiplied, we divide. We do its inverse. So 5 over 5 is 1, so we end up with x equals 30 divided by 5 is 6. 2x equals 20. Divide by 2, divide by 2. That goes away. 20 divided by 2 is 10. Okay, that's pretty much all there is to this chapter, or this section. The only difference is we'll have to give you some that are a little bit more complicated, of course. So, example number 2 says negative 4a equals 24. So, how do we get a by itself? We divide both sides by what is being multiplied by it. The negative goes along with it, and we get negative 6. 24 divided by 4. A negative and a positive give you a negative. Okay, so what if we have, so we did 5x equals 30, and you divided and got x equals 6. But what happens if you have x divided by 5 equals 10? Now you've got a division here, not a multiplication like we had here. 5x is 30. Now it's x over 5 equals 10. Well, how did we get rid of this 5? It's multiplied by x, so to get rid of it, we divided by 5. So if it's divided by 5, what do you think we have to do to both sides? We multiply by 5. Because the key thing, this and this, need to be able to cancel. So x then equals 50. And is that right? Is 50, if we put 50 up here for x, divided by 5, 10? Yes, it is. So that means it's correct. Alright, so let's practice a couple of those, and then we'll kind of combine a whole bunch of stuff together. So if we have negative t over 3, and we say that's equal to 5, what does the rule say? If we divide by 3, we multiply the entire thing by 3, and the other side by 3 as well. So when we do that, then this 3, because this is 3 over 1, and that 3 cancel, because 3 over 3 is 1. Now if you did the math here, you would get, you'd get that if you actually multiplied this 3 times negative t. I mean, we just kept the negative out here, doesn't matter. 3 times t is 3t over 3, because 3 times 1 is 3. Then 3 over 3 is 1, so we just cancel that. So we still get the negative t, regardless of whether we multiply through or we just cancel our 3's like we did up here. So that gives us negative t equals 15. We don't like a negative here. If we don't like the negative, we make it go away. But if we make it go away on the left, we have to move it to the right. Okay? So if you decide that you don't want this negative over here, that's fine. Take it off. In fact, you should take it off. But when you take it off, you also have to move it over here. Okay? So what happens here? We took the negative and we changed the sign to a positive. So if we change the sign over here to a positive, or if we change it to its opposite, we have to change every sign over on the other side to its opposite as well. So this negative t, we change it to a positive. The 15, we had to change to its opposite, negative 15, and then that's our answer. We did a lot of other things to do that, but there's no sense in confusing you with the whys of how all that works, because most math students don't care at this point about the whys, they just want to know how to do it. So we have 2/3 y equals 4. Alright, so we have a couple of options here in order to solve this. That number is being multiplied by y. And what do we do? If I had like 3y equals 9, what did I do? I divide both sides by that 3, and those go away. Well, what happens if I divide both sides by 2/3? That goes away, but that leaves me with a little bit of a mess there, doesn't it? And if you remember, when you divide fractions, because it's 4 divided by, or 4 over 2/3, they both mean the same thing. A fraction is just a division. We can write the 4 is a fraction, and then the bottom number flips over and is multiplied. We never divide by a fraction. We always flip it and then multiply it. Let me have you look at that just for a second. Alright, and then we multiply the top numbers. 12 divided by 2 is 6. Now there are many, many ways of doing this, and you'll find shortcuts eventually. But in fact, one of the shortcuts you'll discover is this is being multiplied by the y, so if I just flip it over and multiply it here, then I'm good to go. And I can just cross this out. That's kind of what we did over here. We just kind of went a roundabout way of doing it. I don't suggest you doing it that way at this point, but that's down the road you'll start doing things like that. Alright, so let's keep going here. Example 5. 5 plus 8 equals 10x plus 20x minus 4x. So remember, we're going to do what's on the right hand side and the left hand side first. We're going to combine things before we do any of the work. 10 plus 20 is 30, minus 4 is 26. Now I've got that being multiplied, so I'm going to divide both sides. And that gets rid of that. So I have 13 over 26 equals x. Now I have to ask myself, can that be reduced? Is there any number, because 26 is an even number, I know 2 goes into it. But how many times does 2 go into 26? 13 times. That's the number up here. 13 goes into 13 once, and 26 divided by 13 is 2. So 13 goes into 13 once, 26 divided by 13 is 2. So actually 13 over 26 is 1/2. Alright, let's go to example number 6. Alright, so this one has a combination of a couple things going on. We have a number multiplied by x and a number added to the x. Alright, so when you're trying to simplify or kind of like undo, you basically look at your PEMDAS, and to a certain degree you go backwards. You do addition and subtraction and then multiplication and division. Maybe that's not the best way to put it. I guess one of the ways that I teach this is I have them look at the x. Let's get rid of the stuff the furthest away from the x first. The 6 is right next to it, so let's leave that 6 there, but the plus 5 is furthest away from it, so let's get rid of that first. And then we work our way toward the x. So start furthest away and work your way toward the x. So there's a plus 5, so how do you get rid of a plus 5? You take it away. You take it away. So then it gives me 6x. Those go away. Negative 13 minus 5 is negative 18. signs are the same. The largest number is negative. You add them and you have a negative on your answer. Now let's get rid of the 6 by dividing both sides. X equals negative 18 over 6. A negative and a positive divided give me a negative. 18 divided by 6 is 3. Okay, let's keep going. Look at example number 7. Example 7 says 5x equals 2x plus 12. Alright, so again, first of all, we notice we have x's on both sides of the equal sign. So let's do that first. It goes away. Okay, now we have all the x's together. 3 times x, so we divide. Goes away. And we're done. Alright, so example number 8. Alright, again we have a negative 2x on one side and a positive 3x on the other. So let's get this one over here. So we do its opposite. It's a negative, so let's add. And that gives me a 5x minus 4. Those go away to be 0. Okay. Now we're still trying to get rid of numbers that are in front or around that x on the same side here. The 4 is the furthest away, so we're going to get rid of that. And it's a negative, so we add it. Again, you do the opposite. So those go away. Negative 4 plus 4 is 0. 6 plus 4 is 10. Now we're going to get rid of the 5 because it's right next to it by dividing both sides by 5. And that gives me x equals 2. Okay, we have 2 more examples to do, and then I'll do a couple of the problems from the homework. Alright, so this is example 9. So let's get rid of the number that's furthest away from the x. And, well, before I do that, so it's a plus 1/2, so let's take it away here, and let's take it away here. And what do we have? 2/3 x, that went away. Can't combine those yet because they don't have common denominator. I've got to make that 1/2 into something with a 4 in the bottom. So we'll leave the left-hand side alone. And 3/4, 4 is the common denominator. So 2 times 2 is 4, 2 times 1 is 2. So now I have common denominator, so I can do this. But let's make this a plus negative here, which you can always do. So negative 3 plus negative 2, sign of the largest is a negative, and their signs are the same, so I add them. Okay. Okay, so now we have to get rid of the 2/3. So we divide both sides by 2/3. Remember, you just always divide by whatever's being multiplied by the x, doesn't matter if it's a fraction or not. And those go away. And remember that when you divide by a fraction, you actually multiply by its inverse, or you flip it upside down and multiply it. You don't divide anything with fractions. Now I multiply, and in that case, in that right here, I'm done because 15 over 8 does not reduce. You just leave it. Now you could write it as a mixed number and get 1 and 7/8, but I don't like those kind of answers. I prefer the improper fraction like we have there. Okay, so I am going to stop this video and go on to 2.3b for example 10, and then some examples from the homework.